video, we're going to be combining vectors and coordinates to solve some shape problems. So let's have a look how we do these kind of questions. We've got A, B, C, D, that's this shape. It's a parallelogram. That will be really important later. We've got the vector A to B is minus 2, 3, and the vector A to D is 3, 5. We get given the coordinates of A, we want to find B, C, and D. I would add, first of all the information that we get in the question onto our diagram. So the coordinates of A are 3, 1. We're writing this down here, 3, 1. We get given the vector from A to B is minus 2, 3. So let's also add this on, minus 2, 3. A to D is 3, 5. So I'm adding on here, A to D is 3, 5. Okay, next we should think then about the properties of a parallelogram. And that means the opposite sides must be parallel. So this side is parallel with this side, and this side here is parallel with this side. So AD is parallel with BC, and AB is parallel with DC. They must be exactly the same length, and they must be parallel. That means the vectors must be identical. So if this vector here on this side is 3, 5, this vector up here must also be 3, 5. And likewise, if this vector here is minus 2, 3, this vector up here must also be minus 2, 3. At this point, we're good to start working out some other coordinates. So I'm going to start off with B. And to get to B, we have to start at A, and then we have to do this vector, minus 2, 3. So I'm going to write down, we've started at A, 3, 1, and we're doing the vector minus 2, 3. We want to find the coordinates that we're going to end up at. When we're thinking about vectors, we need to think minus 2, 3. That means we're going 2 to the left and 3 up. We look at the first number of our coordinate, so it was a 3. If we're going 2 to the left on our x-axis, we need to do 3, take away 2 to get to 1. On our y-axis, we've started at 1, we're going 3 up. So we need to do 1 plus 3 to get 4. So our coordinates of B are going to be 1, 4. If you have a look on the diagram, that does make sense. I'll add this in, 1, 4. We've gone a bit to the left and a bit up from 3, 1. We've ended up at 1, 4. That works. Let's look at point D next. It's our next easiest. So to get to D, we start at 3, 1. We're going to do a different vector though this time. We're going to do 3, 5 because we have to travel along this vector. So we're adding on 3, 5. And again, we should be thinking about, are we going left, right, up, down? Well, look at our first number, it's a 3. We're adding on 3 in our vector because it's positive. So we should get to 6. Look at the second numbers. Well, it's a 1 on our y-axis. We're adding on 5. So we'll also get to 6 for this one. 6, 6 is our coordinate. Now we can do C. So I'm going to write down C here. And to get to C, we've actually got 2 different ways. And it's a really good idea to check both to see if it works. We could go from D and do this vector minus 2, 3 to end up at C. So let's try that. I'm going to go for a different colour as well. So we could start at D, which was 6, 6. And we're going to travel along the vector minus 2, 3. Let's see what happens if we do that. 6 minus 2 should get us to 4. We're looking at the first number of the coordinate, the first number of the vector. If we look at the second numbers, we've got 6, add 3 to get to 9. So I think C would have the coordinate 4, 9. Let's check though, because we've got another way of seeing if we've done the right thing. To get to C, we could also have started at B, and we're doing this vector, 3, 5, to get to C. Let's try it. So we started at B, which was 1, 4. We're going to add on this vector this time, 3, 5. And checking our coordinate, first number is 1. We're going to add 3, because that's our x coordinate in the vector. That will get us to 4. And if we look at the second numbers, we had 4 on the y-axis. We're going to add our 5 to get to 9. Both of those agree with each other that we should end up at 4, 9. So C is definitely 4, 9. We've now found all of our coordinates B, C, and D. Our next question is really similar. We've got another parallelogram. We've got A to D is 6, 1. So let's mark that on straight away as a vector. So this vector here is 6, 1. We've got D to C is 2, 4. So let's mark that one on. 2, 4. We also get given the coordinates of A are 0, 1. So marking our A coordinates, 0, 1. We want to find the coordinates of B, C, and D. Well, let's again use the idea of a parallelogram having equal and opposite sides. So this side here, if this was 2, 4 as a vector, our side AB must also be 2, 4. And likewise, if this side here was 6, 1, BC must also be 6, 1 as a vector. Now we can use these vectors to help us with our coordinates, because to go from A to D, so we want to find point D, you start at A, that was 0, 1, and you have to travel along the vector 6, 1 to get to D. That means we're going 6 to the right and 1 up. While looking at our coordinates, if we start at 0, and we go 6 to the right, we're going to add 6 to get to 6. And if we start at 1 and we go 1 up, we'll get to 2 on the y-axis. So I'm adding in for D, 6, 2. Okay, on to our next coordinate. Let's do C next. To get to C, you start at D, that's 6, 2. You travel along the vector 2, 4 to go from D to C. 2, 4. And let's think what coordinate we'll get to. Well, we started at 6 and we went 2 to the right. So 6 add 2 will get us to 8. When we started at 2 on the y-axis, we went 4 up. 2 add 4 will get us to 6. So for C, we should have 8, 6. And lastly then for B, we can go from A, that's 0, 1. We can travel along this vector 2, 4. And then we end up at B. So looking at our coordinates again, 0, first number, add 2, our first number will get us to 2. And we had 1, second number, add 4, second number, should get us to 5. We've got also another sneaky way of checking if that's right, because we could look at our coordinate for C. So we could look at 8, 6. And we want to take away this vector, 6, 1. If we go back this way, it would be -6, -1, going the opposite direction to get to B. So let's see what happens if we do that. Go from 8, 6, do -6, -1. Well, 8 take away 6 should get us 2. 6 take away 1 should get us 5. Again, agree with those coordinates. That's B, C, and D. Okay, the third of our 4 problems. Again, we've got a parallelogram. We get given this vector, b to c is 3, 2. So I'm going to mark that straight on my diagram, 3, 2. We get given the coordinates of A that are 2, 7. So again, it's going straight on 2, 7. And the coordinates of B are 8, 3. So let's add this on, 8, 3. We want to find the coordinates of C, D, and the vector DC. Okay, parallelogram. We should definitely be thinking if we know this side here, we must know this side here. They're identical vectors. So straight away I'm adding on 3, 2 with an arrow to show that's the direction of this vector. That means 3 to the right and 2 up. So straight away then we're thinking for D, we want to start at A, that's 2, 7. We're going to travel along this vector, that's 3, 2. And that will take us to D. So looking at our first numbers, we've got 2, we're going to travel 3 to the right, so that will take us to 5 on the x-axis. And on the y-axis, 7 add 2 will take us to 9. So I'm adding on D, it's 5, 9. Let's also find out C then at this point. So C is very similar. To get C, we want to start at B, that was 8, 3. We're going to travel along the identical vector, 3, 2. 3, 2, 8, add our first number 3, will take us to 11. 3 adds 2 will take us to 5. So that's my coordinates of C, 11, 5. The last part is slightly different to what we've seen before. We want to find the vector D to C. So that's this vector travelling from 5, 9 to 11, 5. I'm going to show my working in a really similar way. I'm going to write this. The vector D to C takes us from 5, 9. We do something, and then we get to 11, 5. We need to think what the missing numbers are in our vector to take us from 5, 9 to 11, 5. And we split this into x and y vectors. If you look to go from 5 to 11 on our x-axis, we have to be adding 6. It's the difference between 5 and 11. So 6 must go on the top. Then thinking a little bit more tricky for our second part, to go from 9 on the y-axis to 5, we should be subtracting 5 subtract 9 to get -4. In other words, we've gone 4 down to go from 9 to 5 on our y-axis. So that's our missing vector. DC equals 6 minus 4 as a vector. We've now got our 3 missing coordinates and our vector, we're done. On to the very last question of our 4. We've got A, B, C, D is a rhombus, not just a parallelogram this time. The vector C to B is -3, -4. So let's add that on straight away every time we're using the diagram to help us. So -3, -4, that's C to B with our direction arrow. The coordinates of A are -1, 4, and B is 3, 1. So again, we're adding those on. -1, 4, and B is 3, 1. Okay, coordinates of C and D, let's find those. This is a little bit more tricky, this one, because our vector is pointing in the opposite direction. So what we need to do is reverse the direction of that vector, first of all. If going this way from C to B was -3, -4, well, if we want to go the other way, so I'm just going to draw this vector out here, the same thing. The opposite direction, we have to times everything by -1, the opposite direction. So this vector would be 3, 4. We've just got rid of the minus signs. Now we're good to go then. We can do B to C. So to find C, we start at B. That was 3, 1. We're going to add this vector going this way. So we're adding on 3, 4 because we're traveling the opposite direction. See what point we end up at, or look at our first numbers. We started at 3 on the x-axis. We've added 3, that will take us to 6. On the y-axis, we started at 1, we've added 4, that will take us to 5. So I'm adding in 6, 5 on point C. Again, this works. You can check going the other way. If we wanted to look back this way, well, 6 take away 3 is 3, 5 take away 4 is 1. That seems to work. Our next step, think about rhombuses. They're just like parallelograms. The opposite sides must be identical vectors. So let's again add on -3, -4, because we know if this side is -3, -4, this side must be as well. And again, the direction is important. I've changed colour so we're not going to overlap too much, but going back the opposite way is exactly the same thing. If this way is -3, -4, then going back this way must be +3, +4, from A to D as a vector, the opposite direction. So let's write out what we've got. To get point D, we want to do A, which was -1, 4. That's 1, 4. We're adding on this vector of 3, 4, because we're going this direction. 3, 4. Looking at our first numbers, -1, add 3 should take us to 2. 4, add 4 should take us to 8. We've got one more thing that we need to do. And I'll change colour again. We want to find the vector D to C. So if we have the coordinates of D, it was 2, 8. We want to find the vector that will take us from 2, 8 to 6, 5. Let's write down what we've got then. So we've got 2, 8. We want a vector that will take us to 6, 5. I've written my 2 coordinates. My vector must be the thing in the middle. To go from 2 to 6 on my x-axis, I can do 6 subtract 2. It must have been +4. To go from 8 to 5, I could do 5 subtract 8. It must be a take away 3. 8 take away 3 to get to 5. That means my vector DC must be 4 - 3 as a vector.